All right, so here we go. What do we got? 11.3, number 9. So it gives you this drawing. You've got point O, and then you've got a... try that again. Okay, so each of these things has a mass of... Why am I having so much trouble drawing this? It should not be this difficult. All right, so here's our point O. Each of these distances is d. Each of these masses is 0.1 kilograms. 0.1 kilograms. All right, and so each of the d's are 0.06 meters. And so it says, by what percentage does the rotational inertia of the assembly around the rotation axis decrease? And then it gives you a particle. All right, so let's do this. Let's calculate the total rotational inertia right now. Doesn't that seem like that would be a good place to start? Because we're trying to find the decrease, we need to know what we started at, right? Okay, so let's find our total rotational inertia initially. Follow? All right, so remember, you guys, it says that the rod is massless. So basically, we've got 3 point particles. There's one here, one here, and one here, right? Okay, so if I want to find the rotational inertia, it's going to be, well, how would I find the rotational inertia of this first point particle, you guys?
1/3.
Where are you getting the 1/3 from?
I think it's like part of the thing or something.
Okay. So a rod is 1/3 mr squared, but our rod is massless. No, that's okay. Somebody else made the same mistake earlier today. The rod itself is massless. All I care about is the point particles. So do you guys remember what the equation is for a point particle? It's just mr squared. It's just mr squared. Okay? So the rotational inertia of this red one is just going to be, I'm just going to use letters. I don't even know if we need to mess with the numbers. It's just going to be md squared. Yeah?
Sorry, this may be a really dumb question.
You're fine. What is what? That I'm finding? So I is rotational inertia,
Okay.
and we're looking for the rotational inertia of this system.
Where'd you get that equation?
It was in the notes.
It's also in the back of the equation.
It's also, yeah, I mean, one of the things, so when you watched the video, you should have gotten these equations for the different rotational inertias. Okay. And I also told you, that for a point particle, I gave you this, that the rotational inertia for a point particle is just mr squared, where m is the mass of the particle, and r is the distance it is from your pivot point.
Okay, thank you.
Good?
Yeah, I totally got it wrong.
Okay. Gotcha. Yeah, Zach. Or Cameron, sorry.
I used a 1/3 like mr squared equation. I still got the right answer.
Oh, you know, because the 1/3 would be constant. Because you're looking for the percent change and it would divide out.
Okay, cool.
So that's interesting. Yeah. Yeah, but technically, like, if you're doing it accurately, that 1/3 shouldn't be in there.
Okay.
Yeah. Good, good. All right, so is everybody good?
Last thing, the distance, as Joe pointed out, is 0.02, and each d is 0.02.
Oh, is it? Oh, the whole thing is? Oh, the rod. Oh, gotcha. Thank you. Thank you. Yeah, thank you, Joe. All right. Woo! Woo! We'll come back to that. All right, so is everybody okay? All right, so what I just wrote in red here represents the rotational inertia of the red particle, right? Plus the rotational inertia of the green particle would be m times, well, 2d squared, right? Does that make sense? Plus the blue one should be m times 3d squared, right?
Yes.
Are there questions on what I did there? All right, so simplify this, and you end up getting md squared plus 4md squared plus 9md squared, which is 14md squared. Follow? All right, so that's what we start with. Now, the question says, by what percent will it, how's it worded? By what percentage does the rotational inertia of the assembly around the rotation axis decrease when the removed particle is A, the innermost one, or B, the outermost one? So let's pick one. You can do, you know, if you can do one of them, you can do any of them. So which one do you want to do? Innermost? Okay, so if we remove the innermost one, then my total, inertia final will be the same thing, but without this, right? So it'll be 13 md squared. So we lost 1/14 of our inertia, right, from 13/14, or 13 to 14. So we lost a 14th, which is whatever the percentage is. Sorry? 7.1. Does that make sense, you guys?
Yeah.
So, questions? Okay. And you could certainly do it by putting the numbers in if you wanted to, but it doesn't end up mattering. Everybody good? Okay. So that was number 9. Let's see. Next on the list, why don't we do number 8 next?